Hold a single grain of sand in your hand, it feels worthless. Almost nothing, but inside it is a structure so deep, so strange, that human imagination collapses trying to picture it. Trillions of atoms, invisible forces, quantum fields, layers of reality you will never see, only described through mathematics. Now ask yourself something honestly. If we don't fully understand even this one grain of sand, what does it really mean when we say we understand the universe? And if the universe itself is not fully understood, then what happens to our confidence about existence, reality, or even God? This video is not here to comfort you. It is here to expose a simple truth. Most of what we call understanding is only a thin layer on top of a much deeper unknown. Let's begin with something very simple. You are standing on a quiet beach. The air is still, the waves move gently, and at your feet lies an endless stretch of sand. You bend down and pick up a single grain between your fingers. It feels insignificant, almost nothing. Now pause for a moment and ask a serious question. Do you actually understand what you're holding? Not in the casual sense. Not it's sand. That's just a label. The real question is, do you truly understand what that tiny grain is made of, how it exists, and why it behaves the way it does? Inside that grain are atoms, an unimaginable number of them. Each atom has a nucleus surrounded by electrons, not orbiting like planets, but existing in strange probability clouds. Already, this isn't something you can picture clearly. It defies everyday intuition. Go deeper. Inside the nucleus are protons and neutrons. Inside those are quarks, bound together by gluons. Entities that don't behave like objects, but more like excitations of underlying fields. At this level, the word particle itself starts to break down. What you really have are patterns, mathematical descriptions, interactions that we can predict but not fully visualize. Now ask again, do you understand this grain of sand? Because here's the uncomfortable truth. Our best physics can describe it with equations, can predict outcomes with extraordinary precision, but that feeling of understanding, the kind that feels complete and intuitive, slips away the deeper you go. It gets stranger. The atoms in that grain were forged in ancient stars. Long before Earth existed, nuclear reactions inside massive stars created the elements. Those stars exploded, scattering material across space. Over billions of years, that material came together to form planets, oceans, and eventually, the beach where you now stand. So in your hand, you are holding something older than the Earth itself. Now ask a slightly different question. Do you understand how all of that happened? You can trace the story. You can describe the processes. But at every level, there are gaps. Why do the laws of physics allow stars to form? Why do nuclear forces behave the way they do? Why does matter exist at all? Each answer leads to another question. And this is where things become interesting and a little unsettling, because if we cannot fully understand a single grain of sand, something small enough to lose in the wind, what does it mean when we claim to understand the entire universe? What does it mean when we give confident answers about existence, purpose, or ultimate reality? There's a tension here. On one hand, human beings have discovered extraordinary things. We've uncovered patterns in nature, built theories, tested them, refined them. On the other hand, the deeper we go, the more we encounter mystery, not less. It's like zooming into reality and finding that instead of becoming clearer, it becomes more abstract, more subtle, more difficult to grasp. So the honest starting point is not certainty, it's humility. Not because we know nothing, but because what we do know sits on top of vast layers of what we don't. And that changes how we should approach the biggest questions we can ask. There is something deeply human about wanting an answer, even when we don't have one. Imagine a child seeing a magician for the first time. A coin is placed in the magician's hand, the hand closes, and then, suddenly, the coin is gone. The child's eyes widen. This isn't just surprising, it feels impossible. The child immediately asks the most natural question, where did it go? Now imagine that you are standing next to the child, and you don't know the trick either. You didn't see how it was done. You're just as confused. But instead of admitting that, you feel a subtle pressure. You don't want to appear ignorant. You don't want to leave the question hanging. So you say something that sounds like an answer. It went into an invisible world. The child pauses. The confusion fades. The explanation feels complete. The question stops, but nothing has actually been explained. The coin didn't go into another world. You've simply replaced one mystery with a story that feels satisfying enough to end the conversation. The discomfort of not knowing has been removed, but at the cost of truth. This pattern is everywhere. Whenever we encounter something we don't understand, there is a strong temptation to fill the gap. Not necessarily with evidence, not necessarily with careful reasoning, but with something that feels like an answer. Something that closes the loop. Because open loops are uncomfortable. An unanswered question lingers in the mind. It creates tension. It demands attention. And the brain, being a pattern-seeking machine, wants to resolve that tension as quickly as possible. So we invent explanations, not always consciously. Often it feels like discovery rather than invention. The explanation comes to us, and because it feels coherent, we accept it. But coherence is not the same as correctness. Think about everyday situations. If you hear a noise in the dark, your mind immediately tries to identify it. Maybe it's the wind, maybe it's someone moving. Even if you're not sure, you lean toward a guess. That guess reduces uncertainty, even if it's wrong. This tendency becomes much more powerful when the questions get bigger. Questions like, where did everything come from? Why does the universe exist? What is the ultimate cause behind all causes? These are not questions you can easily test or observe directly. There is no simple experiment you can run to settle them. And that makes the temptation even stronger, to accept an explanation that feels complete, even if it doesn't truly explain anything. There is also a subtle shift that happens when an explanation is accepted. Once you believe you have the answer, curiosity slows down. The drive to investigate weakens. After all, why keep searching if the question has already been resolved? In that sense, an answer, especially a premature one, can act like a full stop in the process of understanding. It closes the door. But real understanding behaves differently. It keeps the door open. It allows questions to lead to deeper questions, instead of shutting them down. The difficult part is that this openness requires a kind of discipline. It requires the willingness to sit with uncertainty without rushing to eliminate it. To say, I don't know, and not immediately replace that with something more comfortable. That may sound simple, but it goes against a very deep instinct. Because to admit not knowing is to accept a gap in your understanding. And humans are not naturally comfortable with gaps. We prefer smooth, continuous stories where everything fits together, so we create them. We connect dots, even when the connections are imagined. We build explanations, even when the foundations are unclear. And over time, those explanations can start to feel unquestionable. Not because they have been proven, but because they have been repeated, shared, and woven into how we see the world. The challenge, then, is not just to find answers. It is to recognize when something only looks like an answer, to notice when a statement ends curiosity instead of deepening it, and to be careful, very careful, about the difference between explaining something and simply naming the mystery in a different way. Science often looks from the outside like a collection of answers, equations, constants, laws, clean, precise statements about how the universe behaves. It gives the impression that we are steadily building a complete picture, filling in all the gaps until nothing remains unknown. But that impression is misleading. At its core, science is not a set of final answers. It is a method for asking better questions and testing possible explanations against reality. It doesn't eliminate mystery. It reorganizes it. Take something as simple as an object falling. You drop a stone, and it moves toward the ground. The immediate question is, why does it fall? A common answer is because of gravity. That feels like an explanation, but if you pause and look closely, it's really just a label. You've named the behavior, not explained its origin, so you go deeper. Gravity, in modern physics, is described as the curvature of spacetime. Massive objects like Earth distort the geometry around them, and what we perceive as falling is actually motion along that curved geometry. This is a more detailed and powerful description. It allows precise predictions. It connects to other phenomena. But now a new question appears. Why does mass curve spacetime? And here the clarity begins to fade again. There is no deeper, widely accepted explanation that tells you why spacetime behaves this way at the most fundamental level. The equations work. The predictions match experiments, but the underlying reason, the why beneath the how, remains out of reach. This pattern repeats everywhere. In quantum physics, you can calculate the behavior of particles with astonishing accuracy. You can predict probabilities, interactions, energy levels. But when you ask what a particle really is, whether it's a thing, a wave, a field, or something else entirely, the answers become less intuitive. You are given a mathematical framework that works, but not a simple picture that satisfies everyday understanding. So science advances, but not in the way people often imagine. It doesn't move from ignorance to complete understanding. It moves from one layer of mystery to another, each layer more refined, more precise, but still incomplete. It's like exploring a vast landscape in the fog. You can map the terrain around you. You can measure distances, identify patterns, build reliable knowledge about your immediate surroundings. But beyond a certain point, the fog remains. And as you move forward, you don't necessarily reduce the fog. You push it back. What you gain is not the end of mystery, but a sharper boundary between what is known and what is not. This boundary is important because it keeps science honest. Every scientific theory comes with limits. It applies under certain conditions, within certain ranges. Outside those limits, it may break down or require modification. Scientists are constantly aware of this, even if it's not always emphasized. There is no final theory that explains everything without remainder, at least not one we currently possess. And perhaps more importantly, science does not assume that such a theory must exist in a simple or satisfying form. This is where it differs from the human desire for closure. Science is comfortable with partial answers. It accepts that a model can be incredibly useful without being the ultimate truth. It allows multiple layers of description, each valid in its own domain, without insisting that one must completely replace the others. For example, you can describe gas using temperature and pressure, without tracking every individual molecule. Both descriptions are valid, depending on what you're trying to understand. So, explanation, in science, is often contextual. It answers specific questions, not all questions. And this leads to a subtle but important realization. When you ask why at a deep enough level, you may reach a point where the question itself no longer has a clear scientific answer. Not because science has failed, but because the structure of explanation has limits. Science can tell you how things behave, with extraordinary precision. It can connect phenomena across vast scales, from subatomic particles to galaxies. But when it comes to ultimate causes, why these laws exist at all, it becomes silent, not out of ignorance alone, but out of methodological honesty. It does not invent answers where none can be tested. And that restraint, that refusal to go beyond what can be supported, is not a weakness. It is the very thing that makes science reliable. Because in a world full of possible explanations, many of which feel convincing, science draws a line and says, here is what we can show, and beyond this point, we do not yet know. That line is not the end of curiosity. It is where curiosity becomes most important. Now consider the word itself, God. It sounds simple, familiar, widely understood. But the moment you try to define it precisely, it begins to dissolve into ambiguity. Ask 10 people what they mean by God, and you may receive 10 very different answers. For some, it refers to a conscious being who created the universe and governs it with intention. For others, it is not a being at all, but a kind of underlying force or principle. Some use the word to describe the laws of nature themselves, the mathematical structure of reality. Others think of it as something beyond comprehension entirely, something that cannot be described in human language. So when someone asks, does God exist? There is already a hidden problem. What exactly is being asked? If the word carries multiple meanings, then the question does too. Without a clear definition, the discussion can drift without ever reaching a real point of agreement or disagreement. It's like trying to solve an equation without knowing what the symbols represent. Imagine two people having a serious argument about whether a shadow creature exists. One person imagines a literal creature made of darkness, hiding in corners, capable of independent action. The other uses the term shadow creature metaphorically, to describe fear itself, the way uncertainty feels in the mind. They may argue for hours, each convinced the other is wrong. But they are not actually discussing the same thing. They are using the same words, but pointing to entirely different ideas. This is not a rare situation. It happens frequently with large, abstract concepts. Words give us a sense of clarity, but they can also hide confusion. Once a word is familiar, we tend to assume we understand it, even if its meaning is vague or shifting. God is one of those words. It carries emotional weight, cultural history, personal interpretation. It can represent comfort, authority, mystery, or explanation, all at once. And because of that, it often feels more precise than it really is. Now consider what happens when the word is used as an explanation. If someone asks, why does the universe exist? And the answer is, because of God. It may sound like the question has been resolved, but if God has not been clearly defined, the explanation may not actually explain anything. It may simply replace one unknown with another. To see this more clearly, try a simple substitution. Replace the word God with a placeholder, like X. Now the statement becomes, the universe exists because of X. Immediately the mind asks, what is X? How does X work? Why does X exist? The mystery returns unchanged. This doesn't mean that the idea behind the word is necessarily wrong. It means that the word itself is not a complete explanation. It is a starting point, not an end point. And yet, because the word is so familiar, it often feels like an end point. This is where clarity becomes important. Before asking whether something exists, it helps to ask what is meant by that something. Is it a being within the universe, interacting with it? Is it something outside the universe entirely? Is it identical to the laws of physics, or separate from them? Each of these possibilities leads to very different kinds of questions, and very different ways of thinking. Without that clarity, discussions can become circular. People may defend or reject ideas without ever aligning on what those ideas actually are. There is also a deeper issue. Human language evolved to describe everyday experiences, objects, actions, events within the world we directly perceive. But when we try to use that same language to describe something beyond all experience, it begins to strain. Words like exist, create, cause. These have meaning shaped by time, space, and physical interaction. But if we are talking about something that is supposed to exist outside time or beyond physical reality, do those words still apply in the same way? It's not obvious that they do. So the difficulty is not only about finding answers. It is about forming questions that are clear enough to be meaningful. And that is much harder than it seems. Because when a question feels familiar, we rarely stop to examine its structure. We assume it makes sense, simply because it sounds like other questions we've asked before. But in the case of something as vast and abstract as God, that assumption may be the very thing that keeps us from understanding what we are really asking. Now shift attention from what we don't know to what we do know, because that contrast is essential. It is easy to focus on mystery and conclude that everything is uncertain. But that would be just as misleading as assuming everything is understood. The reality sits somewhere in between. Human beings have uncovered an extraordinary amount about the universe. We know that stars are not eternal points of light, but massive spheres of plasma powered by nuclear fusion. We understand how hydrogen atoms combine under immense pressure and temperature to form heavier elements, releasing energy that travels across space as light. We know that this light carries information. By analyzing it, we can determine the composition of distant stars, their temperature, their motion relative to us. Without ever touching them, we can learn what they are made of. We know that atoms follow consistent patterns. Electrons occupy specific energy levels. When they transition between these levels, they emit or absorb light at precise frequencies. This is why materials have distinct spectral signatures, like fingerprints that allow us to identify them. We know how matter behaves under a wide range of conditions. We can predict chemical reactions, design materials, build technologies that rely on principles discovered through careful observation and testing the devices around you. Phones, computers, communication systems are not accidents. They are built on layers of understanding, each layer tested and refined over time. So there is real knowledge here. Reliable, repeatable, deeply connected knowledge. And yet, something unusual appears when you look closely at this knowledge. It is incredibly effective at describing how things behave, but it becomes less clear when you ask why those behaviors exist in the first place. Take the laws of physics themselves. They are often written as mathematical equations, compact, elegant expressions that capture patterns in nature. These equations allow predictions with astonishing accuracy. You can calculate the motion of planets, the behavior of particles, the propagation of waves. But why these equations? Why do these particular patterns exist rather than others? Why does the universe follow rules that can be described mathematically at all? This is not a small detail. It is a foundational question. Because the success of science depends on the assumption that the universe is, in some sense, understandable, that it follows consistent principles that can be discovered. And that assumption works. It leads to results. But the reason it works is not fully explained. You can think of it like a game with rules. You can learn the rules. You can become very skilled at playing. You can predict outcomes, develop strategies, even discover subtle patterns that others miss. But that doesn't tell you why those rules exist or why the game is structured that way instead of another. The rules are simply there. Now consider another layer. Why is there something rather than nothing? This question seems simple at first, but it quickly becomes difficult to handle. Because any answer you try to give introduces something that already exists, some principle, some law, some entity, and then you are left asking why that exists. It's like trying to explain the existence of everything by pointing to something that also requires explanation. So even though we know a great deal about the universe, our knowledge has a particular shape. It is wide, detailed, and powerful in describing processes and relationships. But at the deepest level, it rests on foundations that are not fully explained. This does not make the knowledge weak. On the contrary, its strength comes from how well it works within its domain. The predictions match observations. The models are tested against reality again and again. But it does mean that knowledge has limits, not temporary gaps that will necessarily be filled with time, but structural limits. Places where explanation may not extend in the way we expect. And this leads to an important realization. Knowing how something works is not the same as knowing why it exists. These are different kinds of questions. Science is exceptionally good at the first. It builds models, tests them, refines them, and expands them. It creates a network of understanding that connects phenomena across scales. But when it comes to the second, why there is a universe at all, why it follows these particular laws, the answers become less clear. Not because the questions are unimportant, but because they may require a different kind of thinking, or perhaps a recognition that some questions do not have answers in the form we expect. So the picture that emerges is not one of complete ignorance. and not one of complete understanding. It is a landscape where islands of knowledge rise out of a vast ocean of unanswered questions. And the more those islands grow, the more clearly we see the ocean that surrounds them. Now consider what it means to explain something. At first, the idea seems straightforward. An explanation tells you why something happens. It gives you a reason, a cause, a mechanism. It turns confusion into clarity. But if you look closely, explanations have a very peculiar structure. They always depend on something else. Imagine you ask why a ball rolls down a hill. Someone says, because of gravity. That feels like an explanation, but as soon as you examine it, you realize it relies on a deeper concept. So you ask, what is gravity? Then you're given another explanation, perhaps involving the curvature of space-time or a force between masses. Now that becomes the new layer. But the moment you accept that, another question appears. Why does gravity behave that way? Why does space-time curve? Why do masses interact at all? Each explanation pushes the question one step back, but it never truly removes it. It's like a chain with no obvious beginning. To make this clearer, imagine a long line of dominoes stretching into the distance. You knock over the first one you can see, and it hits the next, and so on. You can explain the motion of each domino by pointing to the one before it. This one fell because that one hit it. That works perfectly, locally. But now ask a different question. Why is the entire chain moving at all? At some point, you would need to identify an initial push, something that started the sequence, and then you might ask what caused that push. And what caused that cause? The chain of explanation keeps extending. Now imagine there is no visible beginning. The dominoes just keep going, as far as you can trace them. Every event is explained by a previous one, but the entire system has no clear starting point within your view. This is very similar to how explanations behave in fundamental questions. You can always describe how one thing leads to another. You can build incredibly detailed chains of cause and effect. But when you try to explain the existence of the entire chain, the usual method begins to break down, because explanation itself relies on assuming something already exists, some rule, some entity, some condition. Now consider a different analogy. Imagine a book that claims to explain everything. Every phenomenon, every law, every detail of the universe is described inside it. You open the book and start reading. For every question you have, there is an answer on the next page. You keep going, page after page, each answer leading to deeper understanding. But eventually, you reach the first page, and on that page it says, everything is the way it is because of this fundamental principle. Naturally you ask, why does that principle exist? But there is no earlier page. The book has reached its foundation. At that point, the process of explanation stops. Not because you are satisfied, but because there is nothing left within the system to appeal to. This reveals something important. Every system of explanation must rest on something that is not explained within that system. It could be a law of physics. It could be a set of initial conditions. It could be something more abstract. But whatever it is, it acts as a foundation. And that foundation is simply accepted. Now bring this back to large ultimate questions. When someone says, everything exists because of a fundamental cause, you can ask what caused that cause. If they say it doesn't need a cause, then they have reached a stopping point, a foundation. But notice that the same kind of stopping point appears in scientific explanations as well. At some level, there are laws or principles that are taken as given, not derived from something deeper within the same framework. So the issue is not about choosing between having a foundation and not having one. It's about recognizing that any explanation, no matter how sophisticated, eventually reaches a point where it can no longer explain further in the same way. This doesn't mean explanations are useless. On the contrary, they are incredibly powerful within their range. They allow prediction, control, and understanding of relationships. But it does mean that the idea of a complete explanation of everything may be more complicated than it first appears. Because to explain everything, you would need to explain the foundation itself. And if that foundation requires no further explanation, then you have accepted something without explanation anyway. So the process always seems to circle back. Not in a pointless way, but in a way that reveals a limit. A boundary where the question why no longer has a clear direction to go. And encountering that boundary is not a failure of thinking. It is a discovery about the structure of explanation itself. At a certain point, the discussion stops being about the universe and starts being about us. Not the stars, not the atoms, not the laws of physics, but the kind of minds that are trying to understand them. Because the difficulty in answering deep questions is not only out there in reality, it is also in here. In the way we think. Human beings did not evolve to understand the fundamental structure of existence. We evolved to survive in a very specific environment, finding food, avoiding danger, recognizing patterns that helped us stay alive long enough to reproduce. That history has consequences. Our brains are extremely good at certain kinds of problems, detecting movement, recognizing faces, predicting immediate cause and effect. If a branch moves in the bushes, it might be the wind, or it might be something alive. Assuming agency, even when it's not there, is often safer than ignoring a real threat. So we developed a bias toward seeing intention. We don't just see events, we imagine actors behind those events. A rustling sound becomes something moving. A sudden noise becomes something caused it. This instinct is useful in everyday life, but it can extend far beyond its original purpose. When applied to the entire universe, it leads to a natural question. If everything we observe has a cause, perhaps the universe itself must have a kind of cause that resembles intention. Not because we have evidence of such intention at that scale, but because our thinking is shaped to expect it. This is one way the mind fills gaps. Another is through pattern recognition. Humans are incredibly sensitive to patterns. We find structure in music, symmetry in shapes, repetition in events. This ability allows us to discover real regularities in nature. Science depends on it, but the same ability can also lead us to see patterns that are not actually there. For example, if something happens twice in a row, we may start to expect it a third time. If two events occur close together, we may assume one caused the other, even if they are unrelated. This tendency becomes stronger when dealing with complex or incomplete information. The less we know, the more the mind tries to complete the picture. It connects dots, even when some of those dots are imagined. Then there is the issue of uncertainty itself. Uncertainty is not just an intellectual state. It is a psychological experience. It can feel uncomfortable, even threatening. Not knowing what will happen or why something exists creates a kind of tension, and the mind seeks to reduce that tension. One way to reduce it is through investigation, gathering more information, testing ideas, refining understanding. This is the path science takes. Another way is to adopt an explanation that feels complete, whether or not it has been tested. This is faster. It provides immediate relief from uncertainty, and once that relief is experienced, the explanation can become deeply appealing. It feels stable, it feels like solid ground, but that feeling can be misleading, because the comfort comes not from the explanation being true, but from the uncertainty being removed. There is also the influence of language and culture. From an early age, people are given frameworks for understanding the world, concepts, categories, stories. These frameworks shape how questions are asked and what kinds of answers seem reasonable. If a particular idea is widely shared, it can feel self-evident, even if it has not been critically examined. And questioning it may feel like stepping outside a familiar structure. So there are multiple layers shaping how humans approach deep questions. Biological tendencies that favor quick pattern recognition and agency detection. Psychological responses that push against uncertainty. Cultural influences that provide ready-made interpretations. All of these factors interact, and they can make it difficult to distinguish between what is actually known and what simply feels convincing. This does not mean that human thinking is unreliable in general. On the contrary, it is powerful and adaptable. It has allowed us to build knowledge, develop science, and to explore the universe in remarkable ways. But it does mean that our thinking has limits and biases, especially when we move beyond everyday experience into abstract, foundational questions. In those domains, intuition becomes less trustworthy. The patterns we are used to, cause and effect, objects moving through space, events unfolding in time, may not apply in the same way. And yet, the mind continues to use them because they are the only tools it has developed. So the challenge is not just to find answers, but to understand the lens through which we are asking the questions. To recognize that some difficulties arise not because the universe is inherently confusing, but because our way of thinking is not perfectly suited to grasp it. And that realization changes the nature of the problem. It shifts it from, why is reality so hard to explain, to what are the limits of the mind trying to explain it? That is a different kind of question. And it may be just as important as any answer we are searching for.